Alright, here we have 10.3, which is logarithmic functions, and we're going to talk about exponential and logarithmic functions. Now, we learned a while back how to calculate inverses and what inverse functions were. There were functions where the y's and the x's swapped from one inverse to the regular function, and they were we swapped to solve them mathematically. We swapped the x and the y and solved back for y. Now these are two that are a little harder to do that with, but exponential functions and log functions are inverses. So first you're going to graph this 2 to the x and its inverse on this graph below. So 2 to the x, well, if x is -2, then 2 to the -2, which is what you have here, okay, you have 2 to the -2 power, and I'm not going to write all these out, but that would be 1/4 or 0.25, okay, 0.25, okay. Now, 2 to the -1 power is 1/2 or 0.5. And that's what you're going to see in the calculator. 2 to the 0 power, remember x is in the exponent on these exponential functions. 2 to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. And then 2 cubed is 8. Okay, 2 cubed is 8. Now we're going to reverse those. If we know that they're inverses, then when we go over here, we're going to reverse those. So now you have 0.25 as your x and -2 as your y. 0.5, -1, 1, 0, 2, 1, 4, 2, and 8, 3. All right. Now I want to go and plot those on this graph. Okay. Now, it's a little tricky on this graph because, you know, it's hard with me writing with the point. Now, I want to put, if possible, I want to put a line on y equals x. Now, it would be better if it was put it like that. Okay, see if it'll go on there. Didn't want to go on. Let's try it again. There we go. Okay, it'd be better if it was dashed. So we're going to go through. Whoops, it's not going to let me do that. Wanted to put some hash marks in there. Okay, let me see if I can format this line some. No, it's really just not going to let me do it. Let me try one more time. Okay, I'm just going to try to make it kind of a light line and not a very big line and see how that works. So we'll go here, and it's supposed to be a diagonal line that goes, and this one didn't quite make it, and I don't quite know how to fix that. Okay. It should be a diagonal. From this corner, which I can't hit with my finger, to that corner. Alright, that's pretty close. So remember that an inverse is a reflection about that y equals x line. Alright, so let's go and try to graph some points. And we have negative 2.25. So negative 2 about at a quarter. And then negative 1 about a half. Okay, 0 we're at 1. 1 we're at 2. 2 you're at 4. Okay, and 3 at 8. Right there. Okay, and so if I drew that in, it would look something like that. It would get closer and closer to the x-axis, but it would never quite touch. Okay, so that would be, this is 2 to the x power. This one, this line here, this line is y equals 2 to the x power. Now we're going to graph the inverse, which is log base 2 of x, down here. And so it's going to look like this. And so we're at 0.25 negative 2, which is right about there. It's got to be on the positive side. At a half, we're at negative 1. At 1, we're at 0. At 2, 1. And at 4, 2. And at 8, 3. And so this one, this graph comes in something like, okay, all right, something like this, okay, and this line is log base 2 of x. So those are inverses of one another. Okay, and you can't, some of these you can't graph all that well on your calculator, but we're going to try to show how they look just by plotting some points. Now the domain of inverses, this domain is all real numbers on the 2 to the x, and y, the range, is going to be greater than 0. It never quite touches 0. It'll get close, but it'll never be actually 0. The domain on the log function, x, is greater than 0, and y is all real. So the range of 1 is the domain of the, and vice versa. They kind of, just like they swap values, they swap domains and ranges. Alright, so looking at 2 here, log base 3 of x, the inverse of that would be 3 to the x power. Okay, that would be the inverse of log base 3 of x. Now it's much easier to graph the exponential than the log, so let's pick some points for the exponential and we'll graph that. Okay, so we're going to start with negative 2. 3 to the negative 2 is 0.111. 3 to the negative 1 is 0.333. 3 to the 0 is 1. Anything to the 0th power is 1. 3 to the first is 3. And 3 to the squared is 9. Now our reverse points for the log function. Okay. Can plot it then. Go over here and plot it. We'll try to go ahead and put this line on here so that we can kind of see that they are reflections over that line. So we have a point there at -2, we're 0.11, 0.3, 0, 1, 1, 3, and 2, 9. So it's a very similar graph. Not quite exactly the same, but pretty similar. And then this other one at, we have a point at 0, 1. Then we have a point at 3, 2, 3, 1. Excuse me, and at 9, 2. And we have a couple points here that are hard, they're so close to the y-axis that it's very difficult to plot them, but it never gets to the y-axis. It's just really, really close. It never crosses. Alright, so there is the two graphs. This is y equals 3 to the x, and this one is y equals log base 3 of x. Excuse me. The domain of the exponential is all real, and y is greater than 0. And the domain of the log function, x is greater than 0, and the range is all real. Alright, let's look at our next page. More graphs. Alright, this time we're looking for 5 to the x. So our log function, our base is 5, so it's going to be log base 5 of x. Alright, so let's write some points. Okay, if I have -2, well, let's maybe not write so many on this one. 5 to the -1 is 1/5, so that's 0.2. 5 to the 0 is 1, and 5 to the first is 5. So we go reverse those points for the log function. Oh, gotta reverse them. Okay. We look at the graph, put our line in. Okay. And for, if we do our log function first, we have 2, -1. We have 1, 0. And 5, 1. Okay, that should be 0.2, not 2, so that's, I knew that didn't make sense. So we have 1, 0, and we have 0.2 and -1, which is going to be somewhere close to the y-axis. And so that curve is going to come through like this. On this one, the one before it, you have -1.2, 0, 1, and 1, 5 right there. And so that curve comes pretty sharply like that. So again, when we look at domain and range, the exponential has a range of all real, a domain of all real. The log has a range of all real. the range of the exponential is y is greater than 0, and the domain of the log is x is greater than 0. So you're noticing that unless you have a translation of some sort, the domains and ranges of these things are all the same. I mean, they're always the same. For no matter which problem, what base you have, the domain and ranges are the same. Let's look at 1/2 to the x. So we have when x is -2, and this is a little tricky, you have 1/2 to the -2, which means that that's in the denominator. 1/2 squared is in the denominator, so that makes y equals 4. When it's -1, y is equal to 2. When it's 0, it's 1. 1/2 to the first power is 1/2, and 1/2 squared is 1/4. So we reverse. Okay. Now how do we write this log equation here? We write log, the base is 1/2 of x. Okay, graph it, put our y equal x line in there. Okay, put our y equal x line, graph the points. So we have -2, 4, okay, -1, 2, 0, 1, 1, 0.5, and 2.25. So this is an example, remember, of exponential decay. Right? Turns the other way from the other ones. But looking at our domain and range, our domain is still all real. I'm going to go ahead and erase that just so I have room. Domain is all real, and the range is y is greater than 0. Still the same domain and range on the exponential. Now let's draw. We have 4, -2. Okay, right there. Can't get my point located. Then we have 2, -1, 1, 0, 0.5, 1, and then 0.25, 2. Okay, so this one comes in like this. It's very close to that axis, and then goes that way. And you notice they intersect on the y equals x lines. It's one of the indicators that they're inverses. The domain of this is x is greater than 0, and the range is all real. So, again, even though they're shaped a little differently, the domain and range are still the same. Okay, let's move on. This time we're given the log equation, and we need to know the exponential. It's log base 1/3 of x. So my exponential must be the same base, 1/3, raised to the x power. Okay, so it's easier to find the exponential, 1/3 to the x power, when it's -2. Y is going to be 9. 1/3 to the -1, y will be 3. 1/3 to the 0 is 1. 1/3 to the 1 is 0.333, and 1/3 squared is 0.19 or 0.111. We think the domain should be all real, and the range should be y is greater than 0, but we can verify with the graph. Okay, put our y equals x line on. Okay, we have -2, 9. Again, this is going to be an example of decay because our base is 1/3. -1, 3. 0, 1. 1.33 and 2.11, and so our curve comes in here something like that. Okay, and the domain is all real and the range is y is greater than 0. So let's look at our points then for the log over here. Alright, so they're going to be reversed, so it'll be 9, -2, 3, -1, 1, 0, 0.333, 1, 0.111, 2. We believe that our range will be all real and their domain is x is greater than 0, which means it never touches the y-axis. So let's put those points on our graph and see if that's what we get. So at 9, we're at -2. At 3, we're at -1. 1, 0, right there. 0.3331 and 0.111 is at 2. So we're not quite to the y-axis. So this one comes in looking something like this. Really should inch even closer to the y-axis than I showed it, but not cross it. And so our domain and range here turn out to be accurate, even though we didn't, we guessed them before we drew the grid. And that's all there is on this particular homework, graphing these exponential and log functions. So you need to work on your 2 homeworks that you have, and I'll see you tomorrow.